Hi, I am Abir Hasan. My ID is 182010119. Today, me and my team will show how a line follower robot can follow a predefined line. These LFR bots are used for carrying goods, delivery, transportation, and other household needs. Today, I'll be creating the environment as well as the path for the line follower robot. For the floor, I used solid. In the children, I added texture elements to give the floor some texture. I did some minor adjustments in the values to create the floor. Similarly, I created the walls. I too added some texture images to give them some texture, and I also scaled the values to create the wall. I added some lightings to my project as well. For the environmental objects, I added them from protonauts to give the environment a little bit of life. To maintain the factory life vibe, I have given it a factory based theme as well. All of these objects, the floor and the wall, has collision enabled. Now I will use Tinkercad to draw the track for my line following robot. Here I am choosing Scribble. Now I can start drawing the track for my line following robot. As I'm drawing the track, I will be adding proper left and right turns so that I can properly determine whether my line following robot is actually able to determine the line properly. Once I'm done with the track, now I'll be doing some minor adjustment to the track. Now I can export it into my PC as a 3D model object. Once I'm done, now I can finally import the 3D model track into my project. As I can see, the track has been successfully imported into my project. Now I have to do some minor adjustment to scale it back to scale it to my project space liking. Now I'll be doing some scaling to it as well. Now as you can see, the track has been successfully integrated with my space. Now my teammate Mynul Islam will continue the rest. Thank you.
Hello, my name is Mynul Islam and my job was to design the robot. For this robot, we will need a body, 4 wheels and 3 sensors. For line following robot, we will need infrared sensors. I started from adding a base note robot. Inside the children field, I have added a shape. I have also renamed the shape as body. Inside the shape, I have set the appearance as PPR appearance, and inside the PPR appearance, I have used a base color map image texture for giving texture to my robot. And in here I have the source of my texture. I have also changed the metalness. I have also used geometry as a box. We want our robot shape to be box. Then I have changed the scale to 0.1, 0.05 and 0.2, which is a proper size. After that, I made the wheels for the robot. For 4 wheels, we will need to add 4 hinge joint. So I added a base joint, hinge joint. Inside hinge joint, I have set the joint parameters, hinge joint parameters, which I have set the position and the anchor. And also I have added a rotational motor inside the device, which will help to detect motion. Also I have renamed it to wheel 1. Then inside in point solid, I have gave a shape which is cylindrical. I have also used bounding object as wheel and added physics. After that, I copied the hinge joint 3 more times, as we will need 4 wheels for our project, and set the name as wheel 2, wheel 3 and wheel 4, and also gave proper translation and rotation. After the wheels, I will need 3 distance sensors for detecting the light, so I have added 3 distance sensors and renamed them as DS, mid, right and left. Inside the children, the shape and gave PPR appearance and set the color. Also I have set the geometry to box because I want it as a box shape, and also I have used the name as DSMit, which will be used in our code for running the project. And this is how I gave proper translation and rotation to each of the sensors. Then I set the type as infrared.
Assalamualaikum dear faculties, I am Mahbubur Rahman. I have done the controller part of the line following robots. I'll give an overview of a portion of the code and give a brief idea about our PID implementation. First, in the controller module, I have imported the robot class, and then I have created an instance of the robot class. Then, I am getting a basic timestamp from robot.getBasicTimestamp method from the robot class and storing it in a variable to use it further while enabling devices, which will basically update our values after the given time interval. Then, we have created a DS array to store the distance sensor objects, and in DS names array with the names of our 3 distance sensors, the DS left, DS right, and DS mid sensors, which can be found here. And then, I've implemented a list of the same size as the DS names to continuously store and update the values we get from our distance sensors. Then, in a for loop, we're getting the objects of our distance sensors of the robot through the robot.getDevice function using their names and activating the distance sensor objects using our update interval, which we get from the timestamp variable. Then we have a wheels array to store the wheels of our device and the wheel steps array to store our 4 wheels of our robot. Then similarly to previous loop, we are getting the wheel objects through getDevice method. Here we are setting the position of wheels through setPosition method, and it will be infinity since our wheels will move infinitely to keep the robot running. And the velocity of the wheels will be 0 since at the start the velocity will be 0 and it will increase over time according to all conditions. Then comes the PID part, the proportional integral differential control. PID produces an output which is the combination of outputs of proportional, integral, and differential controllers. In our code, we have created the necessary variables to implement PID. First, the previous error variable will help us keep track of previous errors. Then we have the proportional, integral, and differential variables, which are the PID values, and these will be updated using an error value. And then k as the constant, we have the kp, ki, and kd, which are the gains of proportional, integral, and differential control, and these variables will be used further down here. And next, my friend Aditya will explain further portion of the code. Thank you.
So hello everyone, I am Aditya Roy and I'm here to explain the PID implementation part of our project. So firstly I have some variables called previous error, proportional, integral, differential, and the gains of KP, KI, and KD. So I have written a function that takes a parameter called error and calculates the proportional, integral, and differential part with the help of error, and multiplies with the gains and adds those up to calculate the balance, and it returns the balance. I have also a function called setSpeed to set the velocities of the wheels of all the wheels at once with the help of base and the balance, which I calculate using the PID function. Then here I have just calibrated the robot with this print function, and looking at the values, I have figured out that when the right sensor value is greater than 500, it needs to turn right, and when the left sensor value is greater than 500, it needs to turn left. So that's all. And when it's not on the middle sensor value is not 1000, then it means that it's not on the line, so it just moves forward with a speed of 5, and I've just printed that it is searching for a line, or else it just moves forward. So that's all from the code part. Now I just implement it in the Webots and let's see if it works. So I'm just copying the code and taking a new robot controller. I will use Python for this. So I've just pasted the code here, and now I'll just select the controller from here, select LFR, and let's see if it works. Okay, it's working. Yeah, it's working, and it is just printing the states of the robot and what happens if I get it outside the line. Now it is just moving forward, and as soon as it finds a line, it starts following the line and continues running. So that's all from my part. That was our project. Thank you everyone.